Hello everyone, good evening. Dear authors and invited guests, welcome to the technical session 5F. I'm Mansi Soni and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the International Conference on Information and Communication Technology 2023, London, United Kingdom. The 8th edition of this conference is being organized in a hybrid mode. The physical event was held in London on 20 and 21st of February, and the virtual event will be held through Zoom today, that is 23rd of February. I hope you will enjoy the session through the day. So in this session, we have 6 presentations, and each presentation will have a total of 15 minutes, in which 12 minutes for the presentation and the remaining 3 minutes for the questions and answers. On 10 minutes, we'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. And if you have any query or any update, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of this session, Dr. Ruchi Doshi. She is having more than 16 years of academic research and software development experience. She also worked with Bluecrest University College, Ghana, Amity University, India. She is interested in the field of computer vision, cloud-edge computing, and machine learning in higher education. She has published research papers in peer-reviewed international journals and conferences. She is an active member in organizing many international seminars, workshops, and conferences in India, Ghana, Liberia, Denmark, and Ethiopia. I would like to request our session chair to give welcome remarks to all the participants.
Thank you, ma'am Mansi. Welcome to all the authors and good luck.
Thank you.
Thank you so much, ma'am. So now I would like to start with the papers. So first, I would like to invite our first presenter, Maha Zayud, to present this paper on a recent review on machine learning applications and deep learning techniques for handling pandemics.
I will
start with your paper.
Oh, sorry. Okay. I will share my screen now. Okay, good evening all. Good evening, doctors, all authors and participants. Can you hear me?
Yes, we can hear you.
I will start sharing my screen and start with my presentation. Can you see my screen now?
Yes.
Okay. So my paper or my study is about recent review on machine learning applications and deep learning techniques for handling pandemics. This study is done by me, Maha Zayud, and Dr. Soraya Waida and Dr. Rami Al-Haj under the affiliation of the American University of the Middle East, AUM, Faculty of Engineering and Technology. Here's the outlines of the presentation. I'll talk about pandemics in general, COVID-19, machine learning, deep learning for detecting COVID-19, discussion and analysis, and summary of significant machine learning and deep learning techniques, limitations, and finally conclusion and future work. Pandemics actually defined for any infectious disease that can spread over large territories in a rapid speed. Examples in history, we have the Spanish influenzas, SARS, coronavirus, and recently COVID-19. COVID-19 is a severe contagious virus, and the problem of the COVID-19 is the similarity between its symptoms and other normal influenza symptoms. We all know that COVID-19 has symptoms such as a dry cough, high fever, severe headache, body ache, breathing problem, sore throat, which can be also another symptoms for another type of influenza. But the problem of COVID-19 that made it as a pandemic is the rapid spread over worldwide or over large territories due to the symptoms of it, the breath problem. Also, the COVID-19 negatively impacted different aspects of our life. We all noticed the social, the economy, education sector impacts, mental health, many other aspects worldwide. And having such a pandemic, especially with a type or the nature of the virus, the COVID-19, that has the speed of actually improvement, it can be changed from one variant to another. And we notice that how we have different variant like Delta, we have Omicron. So from the initial start until the last variant of COVID, we had suffered a lot. So researchers and scientists highly recommend to use the technology and handling now the new pandemic, not like the old pandemics. So that's why the implementation of machine learning applications, deep learning, artificial intelligence were a must. Machine learning, as we know, it's classified, or if we want to define it, it's actually categorized into two types, regression and classification. Both, they are used to predict and can be used in COVID-19 to predict the virus itself and differentiate it from other types of influenza or other types of viruses. The difference between the regression and classification is in their prediction way. So regression can predict discrete class labels while classification can predict continuous quantities. However, the prediction problem is usually formulated to be a regression task. There are basic machine learning algorithms that are used in many studies, such as the support vector machine, SVM, logistic regression, decision trees, Gaussian naive Bayes, and random forest. All are particularly applied to inceptional voting, or some of them, they are used in actually either as it is, the method is applied, or it can be improved to have a new model or a new solution. All these machine learning algorithm can be combined or some of them can be combined to over several trained models. The prediction performance after having several trained models can be improved, and can be noticed from the high accuracy level of predicting the virus. Uh, how the prediction performance will be improved, because the ensemble model consists of aggregating the response of a parallel machine learning for any complex, whether it's a classification or regression problem. Predicting the virus is not enough. Also, the need of having a right decision after predicting the virus, right decision to treat, for treatment, for procedure of handling the case of the patient also is required. That's why artificial intelligence application and algorithms are needed to predict and make the right decision after being trained, after the data set or after the information is trained. AI is highly recommended by scientists, especially in healthcare sector, and during COVID-19 pandemic was mandatory to be used. In our study, we did not only study or review the papers that were based on machine learning algorithms and AI. We also reviewed other studies that applied deep learning techniques. However, deep learning models consist of deep layers of neural networks. They help in obtaining high-level abstract features. Deep learning techniques lead to high performance results, and they mainly, we noticed that deep learning in COVID-19 were mainly applied or based on CT scan, X-ray images that will be processed in order to make an early prediction of the contagious virus. There are many models in our study that were innovated by the researchers or already models that deployed to predict. We have CNN, which is widely used for the classification and regression analysis. And this is applied for one-dimensional data, specifically for image recognition. Many deep learning methods were suggested to predict COVID-19, and the data set were mainly medical images. Almost of these models are based, as I mentioned, on CT scan or X-ray images. Now let's discuss and analyze the study that, or the review that we did. We noticed that after reviewing the type of the virus, COVID-19, and the pandemic nature, its negative impacts on the society in different aspects, the need to use machine learning and deep learning techniques is actually a must. It will increase the accuracy of predicting the virus. Not only this, having new models that are based on these algorithms, the well-known algorithms, can also help to predict the right decision or to make the right decision in treatment procedure. And of course, it will save a lot of people lives. Here in this figure, we can notice the two types of models that are used for predicting COVID-19. Um, Machine learning, they are like SVM, logistic regression, decision tree, random forest, Gaussian naive, key nearest neighbors, ANN, and XGBoost. While the deep learning, there are some method already there, or some models are extracted from the well-known methods, such as CNN, VGG16, VGG19, mobile NetV1. All these studies are, and researchers, by the way, done in the past 2 years to predict and improve the way of prediction the COVID-19. As a summary of the method that we reviewed and studied, we noticed that each method, it has its own advantages, disadvantages, limitations, and the way how it will be or it was applied. So for example, we can see that in this table, almost of the method are applied on X-rays. Um, Let me just make my screen a little bit clear from this side. So we can notice that almost of the method are applied on X-rays as here and X scanner, CT scan, while some of the method, such as the minimum redundancy, maximum relevance, was applied on the blood test. Other methods are applied on computer software survey, scanner. So the CT scan and X-ray images were the main data set that we noticed in almost of the paper that we reviewed. As an advantages or as advantages for almost of the method, we noticed that the high accuracy rate in predicting COVID-19 was increased, and the high classification of the treatment also increased, while the disadvantages and the limitation mainly were in data requirement. Either the data requirement should be high, or for example, we need to apply huge amount of data, or some method cannot accept a huge amount. It only work with a small sample size, such as the real-time medical data analysis. This is it limited with a small sample size. We have also some limitations, such as the massive amount of label data in deep learning method. Also here we can see the limitation in the fixed size input. Training is required to operate. So even though this method They have limitation, disadvantages, either related to the high cost or required a lot of computational power, hard to explain, or require a lot of data, but it can give us a lot of advantages such as the accuracy, high processing power, read out complex patterns from data, error prone, black box reading, accuracy, time saving. So it has, each one of them has its own advantages, and all these advantages are related to the improvement in accuracy of prediction and saving time. And some of them, they have actually advantage in remote monitoring, which actually can save also the medical staff or the doctor's life from the direct contact with the patients. So as limitations, as from our review study, we can notice that not all the works published in the literature reveal the improvement provided by the application of their machine learning models. Another limitation of this study or the reviewed papers, we can notice the comparative analysis in the literature that may help scholars to conclude the cons and pros of each proposed approach. Also, as a limitation, the computing resources and available data set prevented us as authors from validating some particular result in reviewed work. As a conclusion and future work, in this study, we conducted a review of the application of machine learning, deep learning for defeating COVID-19. We discussed the advantages of applying these models for early diagnosis and prediction. Of course, for COVID-19 specifically, the majority of the studies used data set related to data set from China and USA. And they are basically implemented on data set as X-ray images and CT scan. Only famous and well-known machine learning application were used, as I mentioned in the beginning of this presentation. Also, the advantage of this study, we noticed that many deep learning models are proposed, such as CNN, VGG16, VGG19, MobileNet V1. So too many things are improved either from previous approaches and with some improvement to have better prediction or higher accuracy, or already some implementation was from the same original model. The majority of the researchers, as I mentioned, they use a specific data set type, which is the X-ray images. We can say that these techniques, the machine learning, deep learning, and AI techniques, all they have high impact to detect and defeat COVID-19, especially in the early stages. As a future work, we aim to study the reasons behind the lack of deployment of these techniques in real life. Also, the lack of real deployment, especially in healthcare sector. We may conduct a survey to investigate the awareness that medical resources, they have it about AI techniques, how much how much they are aware of the accuracy of those techniques, and is there any issues in implementing these techniques, such as the lack of training, the lack of confidence between technology and the medical resources. So we will conduct this survey to investigate this level of awareness. I'm done with my presentation. I hope you enjoyed this presentation, and now I welcome any question from your side.
Thank you so much, presenter. Very nice presentation. Now I would
Thank
like
you.
to welcome our second chair for this session, Dr. Ritu Bhargava. Welcome to the session, ma'am.
Thank you so much, Richa. A very good evening to each one of you. Uh, Sorry for joining little late. First of all, I would like to congratulate Maha for wonderful work you have done. So the question I wanted to ask you, like it's a review paper?
Yes, it's a review paper
It's a
about
review paper.
yeah, it's a review paper.
Okay. So another question I would like to ask, like, what is your hypothesis?
We did like comparison between all these models that proposed based on machine learning, AI, and deep learning original models.
Okay.
We wanted to know, as I mentioned in the future work, we made this paper to review the already researches that are done, and we want this review to be base for us to make another step, which is actually the problem of the real deployment of these techniques, especially in healthcare sector. So
Okay.
that's why we started with this review. It's just a start to compare between all these models that have been proposed during the past 2 years. And the next step is to know the problem of the machine learning, and these techniques, especially, they are very important. They help a lot. They increase accuracy. So we need to know what is the reason behind the lack of real deployment.
Right.
Right.
And you have also mentioned medical images you have collected.
No, this is a review paper. We did not collect by ourselves. We
Okay.
reviewed all the researchers that collected data set based on medical images, and they applied their models on these medical images to predict
Okay.
and to make a trained model that can make early prediction of the COVID-19.
Okay. So I congratulate you, Maha.
Thank you. Thank you.
Nice paper.
Thank you.
Thank you so much, presenter and our session chair. Next, I would like to invite our next presenter, Gagandeep Kaur, to present.
Can I close my camera now and make
Yes,
my
you can
microphone
please.
off? Okay.
I would like to invite Gagandeep Kaur to present her paper on the topic Cognitive and Neurocognitive Indicators of Perceived Emotions, Implications for Rehabilitation. So you may please start with your paper.
Yeah, thank you. Is my screen visible, please?
Yes, your
Hello,
screen is
everyone.
visible.
Yeah. Okay. I thank ICICT organizers for this opportunity, and I thank all the fellow presenters for joining for my session. Today, I'll be talking about our paper, Cognitive and Neurocognitive Indicators of Perceived Emotions, Implications for Rehabilitation. This work was done jointly between IIT Kanpur and Institute of Robotics, Bulgarian Academy of Sciences, with Professor Maya Dimitrova. A quick walk through the contents of the talk. I'll be introducing my work, the aim, experimental study, where I'll discuss the cognitive and the neurocognitive aspects. I'll move on to the results and discussion sections, conclude my work, and will be open for an interactive session with you all. The emotional well-being is a significant measure of quality of life, is what inspired us to conduct this study at the first place. And we thought, can we detect human emotions? And if so, can we employ this knowledge into the interventions that are used in rehabilitation, such as behavioral therapies and or brain-machine interfaces for communication for locked-in patients? With this idea, we designed our study that combines EEG recording along with behavioral responses for the purpose of emotion detection. The aim of the study has been emotion detection within the valence arousal model. In a valence arousal model, the valence axis depicts the positivity or negativity associated with a given emotion, and the arousal axis, the y-axis, it depicts the intensity of the perceived emotion. We aim to identify possible factors that can determine the cognitive peculiarities and neuronal activations within EEG frequency maps unique to an emotion. One of the factors that we also wanted to explore was the gender angle. We wanted to see if it was possible to observe differing patterns in male and female perception of emotion with respect to valence and with respect to intensity of the perceived emotion. With this in mind, we designed our study where we sourced the stimulus from OASIS database, which is an open access database, and it has 822 images that are validated on a valence arousal scale. These are some of the images, not all, used in our study. For the EEG recording, I have used 10-20 electrode placement system, and this picture is showing the 16 electrodes, the way they were placed during our experimental study. We used a wireless EEG acquisition system from GTech, and our sampling rate was 100 hertz, and a bandpass filter of 0.1 to 30 hertz was used at the time of signal acquisition. The method, the study method integrated neuronal and cognitive data in the following way. Here I am depicting a single trial. In a single trial, for 4 seconds, the participant was exposed to a visual stimulus, a photograph. During this time, EEG data was recorded, which was later used to analyze the emotion perception. Soon after that, a behavioral response was recorded from the user, where we asked 2 questions. 1, to identify the emotion, and 2, rate the intensity of emotion on a 7-point Likert scale. Once it was done, we analyze the data. I'll summarize our method, which is a unique contribution to existing methodologies for emotion detection. There are 2 stages, EEG recording and behavioral response within a single trial. And this design is close to more of a natural interaction where emotion response to perceived emotion is a manifestation of empathy than result of inference. This is a quick look at the functional divisions of the cerebral cortex for the uninitiated among us. This design is used for the analysis of EEG, and it is shown next. Our results showed, here the results are shown for happy emotion and sad emotion. Generally, it is hypothesized or assumed and also shown by fMRI studies that very local areas of brain are engaged in emotion regulation and processing. What we found in EEG study was that it is rather a complex interaction between various centers of the brain that happens during the time when the participant was exposed to emotion stimulus. We did observe a left hemispheric dominance in case of female participants. The left hemisphere is associated with processing of verbal information, and that is one of the cues that we observed in our results. For the high intensity emotions such as excitement and anger, what we observed was 1, again, the left hemispheric dominance among the female participants, and the occipital area dominance activation among the male participants. Another observation was that for the negative and high intensity emotion anger, something important was missing. This important thing was frontal activity. The frontal lobe of human cortex is associated with inhibition of impulses. It helps us take a calculative decision whenever any impulse comes. So our results are indicating that perhaps emotion like anger suppresses the activation of frontal cortex. It remains to be studied further. For the behavioral results, we had some interesting observation. In this graph, the blue line is associated with the male data. The orange line is associated with the female data. What we saw was single factor ANOVA did not reveal a significant difference between average value for the male participants and female participants in evaluation of the intensity for all the four emotions. But if we remove the most internalized emotion, which is sadness, then a tendency of marginally significant difference of the perceived emotion is revealed. And the exteriorized emotion, just to describe it quickly, are happy, excited, and angry. Sadness is the interiorized emotion. We are not socially trained to express sadness very openly compared to the other emotions. And we also observed that this effect, the same effect, applied to the images with humans in the stimulus, but where it was not seen with the images that had animals in it. The female viewers perceive as more intense of all the emotions compared to the male viewers. So these were our results. And at the moment, we have a few indicative conclusions, not absolute conclusions, and a lot of future work lined up for us. The novelty in our method is that the behavioral input has been recorded right after the image exposure, wherein the possibility of idiosyncratic influences is minimized due to lack of gap between picture exposure and the participant feedback. We have formulated a hypothesis about gender differences in processing the emotions. The results are indicative, if not entirely conclusive, from our data, but will be explored further in future studies, and some of which are ongoing. Both the differences and certain consistencies were observed at individual level in the presented set of the EEG data, and this is also to be explored for a more rigorous study in the future. I acknowledge some of my professors and my colleagues for engaging in discussions for the experimental design. This work has partly been supported by National Science Fund of Bulgaria, which made it possible for us to make this presentation in this conference. I thank you all very much for your attention. I'm open to your queries and feedback. These are my contact details and a small snapshot of how we conduct our experimental studies. That's all.
Thank you, Gagandeep Kaur. Your experience is very good. I just want to know, does this EEG show the depression also? Is it able to measure?
I'll note that for one of our next studies. I have not studied depression using EEG as of now. Thank you.
But it will able to measure or not?
Actually, EEG is a very sensitive measurement, and
Right.
it is very complex as well. And it will be extremely hypothetical to answer this question in yes or no before conducting an actual study. But
Okay.
I mean, you can contact me and we can design the study and see what happens.
Sure. Good. Thank you.
Thank you.
It's a wonderful paper, Gagan.
Thank you. Thank you.
Very, very good work.
Thank you,
So-
ma'am. Thank you.
And I think nowadays everyone is working on this emotional quotient. Many researchers I'm seeing nowadays, it's on emotional quotient. So the work is amazing. And the only question I wanted to ask you, I think it's your part of your thesis. This work is your part of your thesis.
Yes, ma'am. It is part of my thesis and it's in collaboration with Bulgarian Academy of Sciences. I'm working with Professor Maya Dimitrova. She's also right here with us.
So I congratulate both of you.
Thank
And
you.
Very nice one.
Thank you so much for your feedback.
We'll be in touch. It's a good.
I'll look forward to hear from you. Thank you.
Thank you so much.
Yeah.
Thank you so much, presenter, and our session's here. Next, I would like to invite our next presenter, Wilson Huy Iglesias, to present this paper on design of a monitoring system for the environment of a cockfighting band based on the Internet of Things. May you please start with your paper?
Okay. Hello. Good day. Okay. Hello, everyone. My name is Wilson Javier Iglesias. I am going to present the research designs of the monitoring system for the environmental of fighting, cockfighting herbicide on the Internet of Things. This paper is divided into 6 parts: introduction, methodology, development, result, discussion, and conclusion. Introduction. Internet of Things in the birding of fighting cocks. The Internet of Things, IoT technology, has completely changed the traditional way of raising birds in the poultry sector. Feeding its fighting cocks. Nowadays, people and other companies that are dedicated to the birding of fighting cocks have started to use modern technologies such as IoT to improve the quality of everything with the integration of hardware, software, and the internet. One of the biggest risks that have the fighting cook sheet is the entry of pathogens which cause different diseases. For this, it is necessary to have information that helps to prevent and control this pathogen. Cockfighting is quite popular in many Asian, Central, and South American countries. It is also true that it represents one of the oldest and most genuine traditional of the United States. The poultry sector in recent years has had great advances. Technologies have been employed more intelligent and automated methods, such as radio frequency technology, IoT, Bluetooth communication protocol for monitoring and control. Likewise, there is environmental control in poultry houses, research and implementation of automatic monitoring systems together with mobile networks and cloud platforms in poultry systems has provided use with new ideas for developing similar poultry monitoring system. IoT has become one of the most important technologies. Although IoT technology has advanced in many aspects in the poultry sector, specifically in the birding of fighting cocks, there are no tools that provide timely information on the environmental variables of the environment. IoT contributes in a lot in the poultry sector. It not only saves time for those interested in the monitoring the sheets, but also substantially improves the growth of fighting cocks, generating a direct economic benefit for the owners. Methodology. The P methodology is used in various software development processes, which represents a sequence of steps in the life cycle of a project. This methodology allows to bring together a cross-functional team, which means that members can work collaboratively and self-manage as a team. Development. We can see in this picture general system architecture. The system is divided into 3 layers. The upper layer where the system is managed, the intermediate data service layer, and the lower layer which includes the hardware installation and the sheets. Number 1, upper layer, the top level manages software that provides a graphical interface divided into a monitoring module and a system administration component. Number 2, intermediate layer. As for the middle tier data services, layer hosted in the cloud is used to store the information generated by the lower and upper tier, and at the same time a reciprocal communication network is created through the server configuration. Bottom layer, in the low layer in the sheets, the environmental sensor, a receiving device, Wi-Fi transmission, and single chip microcontroller allow timely configuration of the environmental parameters of the sheets to obtain information on temperature, humidity, and air quality, and other equipment placed in the sheet. Bottom layer management system. The lower layer of the system is mainly composed of wireless sensors that is used to manage the data information that has been previously uploaded. The wireless sensor networks in the chip, it is understood that all the sensors are connected to a server. The server has the following features: a wireless network card, an Intel Core TM i7 processor, a 16 GB RAM, memory DDR4 at 3 to 100 MHz, as two main features, among others. For the processing and uploading of the data generated by the terminal node, a web system was developed to archive the respective monitoring. Implementation of the web system for monitoring. For the implementation of the web monitoring system, the following tools were used: MariaDB, PHP, Apache Web Server, among others. The system was developed to integrate to modules: system administration module and variable monitoring module, and is managed through roles established for each stakeholders. In this picture, in this image, show a section of code where the programming of the humidity and temperature sensors and the results of time as a test from a terminal of the programmer can be observed. Results. In these results, the object of this research is to determine to what extent the implementation of an IoT-based web system improves the monitoring of temperature, humidity, and air quality in a feeding cook sheet. The indicator are time to determine temperature, KPI1, time to determine moisture, KPI2, time to determine air quality, KPI3. Data collection was carried out by means of an optation sheet and automated record. In the bar graph showed that the average of the three KPIs has been reduced considerably, and therefore it can be said that the time required to measure the indicator has improved. The result of time for each KPI, both pre and post, we performed for a period of 12 days. A considerable decrease in time was evident for each indicators. So means that the web system with IoT support tools to reduce the monitoring time of temperature, humidity, and air quality. Discussion. KPI 1 time of to determine temperature. The individual standard deviation of KPI 1 time to determine the temperature with respect to the means is 2.36 seconds, approximately 95% of the time determined the temperature is within two standard deviation interval of the means, i.e. between 28.03 and 29.63 seconds. And then KPI2, the individual standard deviation of KPI2 time to determine humidity with respect to the mean is 2.636 seconds, approximately 95% of the time to determine the humidity is within two standard deviation interval of the means, i.e. between 28.03 and 29.63 seconds. KPI3, the individual standard deviation for KPI3 time to determine air quality with respect to mean is 2.360 seconds, approximately 95% of the time to determine air quality is within two standard deviation interval of the means, i.e. between 28.03 and 29.63 seconds. Conclusion. A significant improvement in the time to determine the temperature of the house was evidenced, allowing a decrease in time from 310 to 28.83 seconds. Likewise, the time to determine the humidity was reduced considerably from 313 to 28.83 seconds. In the same way, the time to determine the air quality was reduced from 311 to 28.83 seconds. The changes in time has been satisfactory, considering that at first the monitoring of temperature, humidity, and air quality was carried out in the traditional way. The results have made it possible to manage the heat in a better way, creating the best conditions for the growth and performance of the fighting goods. Thank you for your attention.
Wilson, am I audible? Can you hear me?
Yes.
Yeah. So I found it very unique paper. So congratulations. Just wanted to know, did you face any challenges while setting up all this sensors and to find out the results?
Yes.
Did you faced any challenges during this research?
Can you repeat, please?
Means any risk because the sensors you are um, means implementing for the growth and performance of the cockfighting. So it went well, or you find some problem while implementing it? Because sensors are sometimes very delicate.
Yes.
Sometimes they don't work. So did you find any kind of challenges during writing this research paper?
Yes. Thank you.
Okay. Thank you.
Thank you.
Thank you so much, presenter, and our session's here. So next, I would like to invite our next presenter, Ingrid Herga, to present this paper on measuring the sensitivity of image captioning matrices to caption perturbations. May you please present with your paper?
Thank you. Let me share my screen. Can you see my screen?
Yes, we can see your screen. You may start.
Great, thank you. So hello everyone, my name is Ingrid Herga I'm a PhD student at the University of Rijeka in Croatia, and I will present the results of research conducted with my supervisor, Marina Ivačić-Kos, on the sensitivity of selected image captioning metrics. The content of the presentation is as follows. First, in the introductory part, I will explain the motivation and the goals of the research and why it is hard to evaluate captions. Then we will briefly review some of the most commonly used image captioning metrics. And in the next part, I will explain the methods used in our research and experimental setup. Then I will summarize the results of caption perturbation experiments. And finally, I will conclude and propose some guidelines for future research. Image captioning is a task of automatically describing an image with one or more natural language sentences, which means that first it is necessary to detect objects on the scene and then express the image content with properly formed sentences. Over the past few years, image captioning systems based on deep neural networks have made significant progress in generating image descriptions in fluent language. However, despite the achieved success, one of the main challenges still remains the evaluation of the results. An image can be described in different ways, depending on which aspect it is given more importance, and each of these descriptions could be accurate and perfectly suitable. Moreover, two descriptions can contain almost the same words, but convey completely different meanings, which makes evaluation very challenging. For example, you have two images with captions. In the first case, the sentences share some words, but the meaning is completely different. And in the second case, the captions don't have any words in common, but both have the same meaning and are good description of the image. And humans don't have problems recognizing this, and machines still struggle. So it will be best to have humans evaluate the generated descriptions. But this will be not possible during training, and moreover, human evaluation is very slow, expensive, and highly subjective. And for this reason, automatic evaluation is usually preferred. A good automatic metric should match the ratings human evaluators will assign to captions, meaning that captions that are considered good by humans should get higher scores, and vice versa. And as more and more metrics are being proposed, it also becomes very important to find appropriate ways to compare them and to choose the best one. So a common way to evaluate automatic metrics is to calculate system level and caption level correlations with human judgments by using publicly available datasets, which contain human ratings in addition to images and descriptions. However, this approach does not provide insights into the subtle differences between metrics and how to deal with various errors in the descriptions. So in this work, we took a different approach. We analyzed how various caption perturbations affect the scores of selected image captioning metrics. The goal of the experiments was to discover how well a metric can capture subtle changes in captions. And for this purpose, we created a set of descriptions consisting of captions and several of their modifications, in which individual words or characters have been replaced, inserted, or deleted. And then we computed evaluation scores for the selected metrics. And finally, we analyzed differences between the scores assigned to the original captions and those assigned to their modifications. Automatic image captioning metrics can be categorized according to the inputs they take to calculate the score into reference-only, image-aware, and reference-free metrics. Reference-only metrics compare the candidate or generated caption with one or several human written references considered as ground truth. Image-aware metrics take also the image into account when calculating the score, and reference-free metrics compare the candidate caption only with the image. And this is a desirable goal because it is how humans evaluate descriptions. Humans do not need references to judge whether a description is good or not. Another categorization can be made according to the approach the metrics used to calculate the score into rule-based, learning-based, and embedding-based metrics. A standard set of automatic metrics consists of Blue, Metro, Rouge, Cider, and Spice. They are rule-based reference-only metrics, and some of them were borrowed from other tasks, such as machine translation or text summarization. Only Cider and Spice were developed specifically for image captioning. And all those metrics output a score that quantifies the match between the generated sentences and the reference descriptions. But a major criticism is that they don't show strong correlation with human judgments. And this was particularly evident during the Microsoft Cocoa Captioning Challenge, in that some models outperformed a human upper bound according to automatic metrics, but human judges demonstrated a preference for human written captions. The scores assigned by human judges to image captioning systems were considerably lower than those assigned by automatic metrics to the same systems. And for this reason, caption evaluation represents an active area of the research. For example, in contrast to rule-based metrics, some authors propose learning-based metrics, which can learn a model to distinguish machine-generated descriptions from those written by humans. However, such learning can be very slow or require significant computing resources, which makes application impractical. And more recent works are based on the use of retained models for mapping candidate and reference descriptions or descriptions and images into a common vector space where cosine similarity can be easily computed. And this shows a promising direction, as such metrics more closely match the ratings that will be assigned by human evaluators. For example, BERT score uses BERT, a language representation model retained on a very large corpus of text, and creates contextual embeddings for each token from the sentence. Because it uses the whole sentence as the context, this allows better handling of polysemy when a word has more than one meaning. BERT score is also a reference-only metric, which computes the cosine similarity between candidate and reference tokens. On the other hand, CLIP score uses CLIP, a multimodal vision and language model with two encoders, one for the image and one for the text, to create the vector representations. The score is obtained based on the cosine similarity between the image and the candidate caption. And in addition to reference-free CLIP score, the authors also propose reference CLIP score, which can be computed when references are available. An inspiration for this research and the starting point for generating caption perturbations was the foil COCO dataset, which consists of approximately 300,000 captions, original and modified, for nearly 100,000 images from the Microsoft COCO dataset. Each modified sentence has exactly one word replaced by another from the same COCO label supercategory, as shown in this example. But is replaced with cat. To construct our dataset, we randomly selected 1,000 images from the Microsoft COCO dataset, along with almost 3,000 sentences. We used the following approach. First, we tokenized the sentences, and as we didn't want to add too much randomness, we chose only nouns, verbs, or adjectives as candidates for substitution, deletion, or replacement. For this, each token was tagged with its part of speech tag. We then used WordNet to find synonyms or antonyms for the selected candidates. WordNet is a large lexical database in which words of similar meaning are grouped into synths or sets of synonyms. And after preparing the dataset, we computed the scores on the original captions and transformed captions. Some metrics use references, and some metrics use only the image. And here's an example, an image with the corresponding original caption. So the use and transformations are character-based transformations, such as Butterfinger, which replaces a randomly selected character with another character close on the keyboard, similar to typing errors. And this adds noise to captions. Some word-based transformations are replacing a noun, verb, or adjective with a synonym, a word with a similar meaning, or replacing with an antonym, a word with the opposite meaning. Then gender swap, subject and object switch, inserting a synonym, inserting an antonym, inserting one or more filler words. Those are words that add noise but don't contribute to the meaning. And word deletion, again, the chosen word can be a noun, verb, or adjective. And as for the metrics, we chose the standard sets of metrics and BERT score as an example of embedding-based reference-only metrics, and the CLIP score as an example of an embedding-based reference-free metric. We also compute reference-based version of CLIP score. And for each of the metrics, we compute system level and caption level scores. And now on the results. This table shows percentage change in system level scores of the transformation of the transformed captions compared to original captions. We can see that for almost all metrics, the biggest score drop was because of the added noise, such as Butterfinger and filler word insertion. If you look at the replacement of a specific word with the antonym, A word with opposite meaning, then matter and spice show the biggest change, especially if the word was a noun, while the smallest change was for adjectives. What is interesting is that CliffScore in both versions reacted rather weakly to the substitution of verbs, which may indicate insufficient understanding of the activities shown in the picture. It can also be seen that only Blue 1 and Blue 2 showed an increase in scores when deleting some words, especially in the case of adjectives. So given that Blue is based on exact n-gram matching, these were likely words not present in the references. So the exclusion had a beneficial effect on the scores. In all other cases, the scores decreased. Other metrics responded more strongly to the deletion of nouns, while the impact of deleting adjectives and verbs was significantly smaller. And given that image caption systems are largely object focused, this kind of insensitivity to errors related to verbs and adjectives may give systems higher ratings than might be appropriate. Insertion of redundant words, either synonyms or antonyms, generally did not have a significant effect on the scores. And here, CliffScore, reference CliffScore, and Matter showed the greater resistance to such as change. But the gender swap is particularly interesting. The biggest change in scores occurred in both versions of CliffScore, while BERT proved to be the least sensitive. And why BERT reacts so weakly to gender substitution, it's something that certainly should be further investigated, especially since it is known that large language models are not immune to gender bias. On the other hand, the subject-object swap had a significant effect only on BERT and Rouge, and to a lesser extent on Blue. And this raises the question of whether metrics can really detect the nuances in language and whether they are suitable for giving a general assessment of a system if they do not respond to such semantically important changes. Here we can take a look at the individual metrics more clearly to see which transformation had the biggest or smallest impact on the scores. And here is a comparison of the distributions of caption level scores computed with BERT and BERT score and CliffScore on original captions and select transformations. So we can see that this metric reacted differently to those transformations, to the change of verbs, insertion of noise or redundant words, and gender swap. And this indicates that those metrics could be considered complementary. And to conclude, in this work, we analyzed the sensitivity of selected image caption metrics to various caption perturbations. The experiments showed that metrics respond differently to changes in sentences, but almost all of them respond more strongly to the addition of noise. Some reactions to some semantically important transformations, such as gender swap or subject-object switch, were significantly less intense than expected, indicating that there is still no metric that can cover all aspects of captions. Therefore, this analysis could help to find complementary metrics and provide insight into possible weaknesses or insensitivities that could be used to artificially increase the score of a system without increasing the quality of the output. One limitation of the research is that we relied only on WordNet to choose synonyms or antonyms, and in our future research, we will use some of the more advanced models for computing similarity in embedding space. We also intend to expand the research to a larger set of current metrics and to analyze the outputs of image capturing systems as well. Thank you.
Congratulations, Ingrid. It's a very quality work.
Thank you.
So I just wanted to ask you how you have cleaned the images, the noise. I'm talking about noise clearance.
Could you please repeat? I didn't understand the question.
I just wanted to see how you have removed noise from your images.
In our research, we didn't use images were from the Microsoft Coco dataset, and most of the metrics didn't use images. Only CliffScore used images, but other metrics compare only the generated caption with the candidate captions. So we didn't process image in particular ways. We just used raw images because this is how this model works.
Thank you.
Thank you.
I want to know if the image is grayscale. So there is any effect during the pixel conversion?
The images are in color RGB, but if maybe I didn't understand the question. Could you please repeat?
I'm saying if your image is in the grayscale, is there any effect in the pixel?
We didn't try converting all images to grayscale, but this is something that is used as a part of data augmentation, and the models usually when models that are trained usually use data augmentation, and as a part is also convert some images to grayscale. But I'm not sure if this is really used when training a CLIP model, because CLIP model was the only one that uses images in this from the metrics that we use in this research.
Okay, thank you.
Thank you, presenter, and our session's here. Next, I would like to invite our last presenter, Maribel Karina Flores Ramirez, to present present her paper on web system with RFID technology to improve the internal control of attendance. You may please start with your paper.
Good afternoon, distinguished members of the ICICT committee. My name is Maribel Flores. I am from Universidad Privada del Norte and Michael Cabanillas. I am going to present in the paper with the title is Web System with RFID Technology to Improve the Internal Control of Attendance. This paper is structured in 4 parts: introduction, methodology, result, conclusion. Introduction. Controllogy, the assistant records of the teachers and the student ensures the viability and reliability of the information required at any given time. The design and development of an automated process system with a radio frequency RFID system for the Instituto Peruano de Turismo y Finanzas, IPT Peru, will allow to the automate its process, a mechanical attendance control system for administrative area, the labor field, that controls the time of arrival and departure of the worker, plus his signature for the administrative process is tedious for the counting of hours and payment of their hours. It is a manual process that takes time and resource. RFID. What is RFID? RFID is a form of wireless communication that incorporates the use of electromagnetic or electrostatic coupling in the radio frequency portion of the electromagnetic spectrum to uniquely identify. RFID allows radio frequency reading. That means that the to not have to be visible and data can store more information about the product. RFID types. There are 3 types of RFID: active, semi-active, passive. In this research, use passive RFID. Passive tags do not have a boiling power supply. They use the electromagnetic field generated by the reader to activate and transmit data. The advantage of this type of tasks are their low acquirement and maintenance costs. Their size is smaller than active and semi-active tasks. The main disadvantage are the short distance for the reading range between 3 cm and 9 meters approx. The additional sensors. Methodology. Scrum. For the development of this work, the Scrum in the figures show the life cycle of the Scrum methodology. Investigate, design, and type. According to its approach, this search is considered an experimental time development, quantitative and qualitative research. According to its purpose, is applied research seeks the resolution of a certain problem, and it is objective in is the application of chronology of theories to give an answer to a specific problem or need. It generally takes a certain question and tries to find a definitive and complete answer. Classified on the basis of the degree of manipulation of variables, it will be experimental investigation. It is any research conducted with a scientific approach where one set of variables keep constant while the other set of variables is measured as the subject of the experiment. Phases for the development of the technology solution. Phase 1, at this stage, the definition of the cost of development tools, working sprint planning solution technology architecture was carried out. Now, phase 2, at this stage, the development of the sprint that were planned in the previous phase is carried out. Each sprint contains user stories, and each sprint relates to a set of engineering tasks. And phase 3, in this phase, the expected installation of the web system was carried out when deploying IPT system in the SQL server, which is the operating in the cloud. In the same, when the respective user manuals of the system were developed as well as the respective training was carried out, the personnel involved in the management of the web applications. Subsequently, the relevant delivery of the web application was made. Infrastructure. In this image is the modeling of how the software works. The NFC RFID first communication with the hardware RFID, second with the Raspberry Pi, and finally the information is stored in the database. Results. Normalities. To carry out the hypothesis test, 40 people were taken as samples for which the Shapiro-Wilk normality test will be performed. In this work, it is mentioned if the significance level is less than 5%, it is determined that the sample does not come from a normal distribution. Otherwise, greater than 5%, it is determined that it comes from a normal distribution, that is, the null hypothesis is accepted. See figure. The Shapiro-Wilk formula, with the help of SPSS software, the following formula will be used to obtain the result. As shown in table 11, the significance level has a value at 0.000, which is less than 5%, or in decimal, which is a 0.05. Therefore, the null hypothesis is accepted and the alternative hypothesis is rejected. In conclusion, that the variable internal attendance control has a normal distribution. The information collected was the process in the SPSS software in order to interpret the result that is performed during the sample pretest and post-test. Pretest. This part details and analyzes the result obtained from the data collection, these data are based on dimension and variables related to research. The table 12 and figure 12 result where 35% is high, 55% is moderate, 10% is low, 0% is very high and very low. Describe analysis of the pretest reliability dimension. In the table 13 and figure 13 result where 13% have a high level, 78% have a moderate level, 10% have a low level, 0% have a very high level and very low level. Describe analysis of the usability dimension pretest. The table 14 and figure 14 result where 5% is high, 80% is moderate, 15% is low, 0% is very high and very low. Now post-test. Describe analysis of the variable post-test attendance control and the table 15 and figure 15 result where 100% are high, 0% have a very high level, moderate, low, and very low. Describe analysis of the post-test reliability dimension. The table 16 and figure 16 results where 5% is high, 95% is moderate, 0% is very high, low, and very low. Describe analysis of the usability dimension post-test. The table 17 and figure 17 results where 5% is high, 55% is moderate, 10% is low, and 0% is very high and very low. In conclusion, nowadays institutions have been forced to develop new strategies that allow them to grow and research more users. This circumstance led to the objective of the present research work, which was to determine the influence of the implementation of a web system with RFID technology based on the Scrum methodology to contribute to the improvement of the internal attendance control process based on the EPT. From the data obtained, it can be inferred that for the post-survey of purchase time, an average value of 55 was obtained, which represent a reduction of 45.6%, and for administrative staff satisfaction, an average of 90.55 was obtained, a mean value of 40.55 was obtained, representing an increase of 150%. It is concluded that the RFID-based system has a positive influence on the institute since it allows a reduction in internal control time, thus achieving the objectives expected in this research. In addition, it is concluded that the web system RFID has a positive influence on the satisfaction of those in charge of the administrative part of the IPT Peru, Lima, since it allowed to increase the degree of satisfaction, thus achieving the object specific in this research. Thank you so much.
Thank you for your wonderful presentation. Can I know the limitation for your research work?
Based on the result obtained in this paper, It is absorbed in the discrete analysis of the pre-test and post-test of the usability dimension that the highest frequency of acceptance is found in the crossover of the moderate category of the post-test and moderate of pre-test.
Okay, thank you.
Any other question? Okay. So,
Thank you, Marble. It's a wonderful presentation. No question from my side.
thank you so much, presenter, and our sessions here. I sincerely thank our author for their excellent presentation in this session and all our participants for being a part of this international conference. I hope this session was knowledgeable enough for you all. On behalf of our whole team, I want to thank you for the support during this 8th version and the previous 7th version, and we will be happy to have you in the 9th version in 2024. All the participants would be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer, and their presentation will be live within 6 months. Kindly cooperate with the team ICICT 2023. I also want to thank our session chair, Neetu Bhargava, and for chairing the session. And this is a token of appreciation to the chair on behalf of our whole team of ICICT 2023 and Global Knowledge Research Foundation and partners. And I also want to thank our second session chair, Ruchi Doshi, for chairing the session. And this is a token of appreciation on our behalf of our whole team. Thank you so much, Ruchi Doshi, and thank you so much, Ritu Bhargava. Now I would like to request you all to switch on their cameras for a quick snapshot of this virtual conference. Thank you so much to all the participants in our sessions here.